Hello guys, welcome to my video. Today I'm going to show you how to take a measurement using the etracer here. So today we are going to test two tubes, the EL156 from Telefunken triad connection and the 12AX7 triad twin triads. Okay. So this is the etracer, okay, and so it's now connected with the AC. The voltage here is 115 volts in Taiwan, and in US too. In Europe it will be the 220. And this is the USB Type B connector connecting etracer to the controlling computer. Okay, so let's turn on the power. And connect. Then we can download the tube configuration file here. Okay. Plug in the tube 12X7. So here we'll see the how to connect the output of the PCB to the corresponding pins. So here we can see heater is connected to pin 4 and pin 5. Okay, so I have color code here. The heater is marked with green, negative supplies yellow, ground is black, and the high voltage output is red. I'll probably replace these connectors with blue ones or white ones, so it will give you a very clear picture on which to connect. Okay, so now let's connect the heater to pin 4 and 5. And actually, now we can turn on the heater. Okay, once the heater turned on, we can see on the here we can see the current heater supply voltage and the current the current. Then we can connect the rest of the pins according to the table here. So pin 1 to HV1, pin 2 to negative voltage output. This is the grid connection. Pin 3 is cathode, so it connects to the ground of the PCB. HV2 connects to the pin 6. That's a plate for the second unit of the twin triad. Pin 7 to negative voltage output. So here you can see why we have two rows for the PCB output. That's because for this twin tube, twin triad tubes, you really need to output to connect both units. Okay, so the connection is complete. Now we can do a first we can do a quick scan here. So let's do a quick scan. A quick scan is really quick, so it will scan the 9 points and get the parameters around this area. So here we can see section 1. The current is 1 amp. The resistance, the plate resistance is like 60k ohms. The mutual conductance and the amplification factor, and this is the the parameters for section 2. So looks like the section 2 has a better readings compared to section 1. Okay, now we can do a full scan. Run. So normally when we test the tube, we only need to do a quick scan. So that's I mean, you will probably spend more time waiting for the heater to heat up than the real measurement. And when running a full scan, it depends on how many data points you want to you're taking. So you will the test time will spend from like 1 minute to 2 or 3 minutes. Okay. Okay, so here we have two LEDs lights. That means the high voltage output is well above is above 50 volts. So means be careful about the voltage. Okay, here I show the current point taking measurement. So we can see currently we are taking measurement at the voltage of 240 on the plates, and this is a negative voltage applied on the grid. So here we can see the green line is the current reading for the high voltage output 1, and the red line is for the high voltage 1, and the green line is for the current reading of high voltage 2. So this is section 1 of the twin triad. This is the section 2. So we can see there's a difference between these two. So depends on the application. Someone might consider this tube not matched, but for most application, I believe this tube is good enough to take the job. Okay, so the measurement is done. Let's swap tube. So let's we switch off the heater. We don't need to disconnect, and plug in the EL156. Okay, remove all the wiring. Download the tube configuration data. So we are going to test the EL156 in triad connection. So again, here it shows how to connect the output from the PCB to the device under test. So pin 2 and pin 3 connects to heater, and here this time we can turn on the heater voltage, heater supply, and we can see here when the heater is cold, it will draw a lot of current, well above 4 amp. Okay, so the plate connect to HV1. Plate is number 5. HV2 to the screen. Negative voltage to pin 8 and ground to pin 9. And so we don't need these two. Yeah, we can relieve the ground here. It should be okay. Anyway, let me remove it. Okay, so now we are ready to test. Okay, so this time the test will the curve scan will be much longer because we are taking at each high voltage point we are taking 12 readings. We from 0 to -48 at the step of -4. So it's a lot of steps. So again, we can observe the current progress by reading these values. Okay, here we can see the red line represent the sound current from both high voltage supply. This is needed because the current plate current is the sum of the the total current is the plate currents and the screen current. So plate current is reflected down at high voltage 1 and supply 1, and the screen current is reflected on the high voltage supply number 2. Okay, and the green curves represent the screen current only. So by looking at this graph, we know the total current, and we know the amount of screen current at each bias point. Okay, the test speed is not great at this moment because I think it's more important to make sure the system is stable before I try to optimize the speed. So we'll see. Again, this is for a full curve scan. If we only want to do a quick test, then the test time is much shorter. It's like within 10 seconds you get the parameters, and I think that's it's good enough for everyday use. Okay, so we scan all the way to 650 volts, and here we get the interpolated data. We can choose to save the measurement data for further analysis. That's it. So it's very simple to use etracer. Okay, so thanks for watching, and I hope you like my etracer, and you like my video. See you next time.